Differentiating with the chain rule. When do we use the chain rule? We use the chain rule whenever we need to get the derivative of a composite function, meaning you have a function that is composed of another function. So the formal definition of the chain rule is if v of x is equals to f of g of x, then v prime of x is equals to f prime of g of x multiplied by g prime of x. So what this means is v of x is composed of two functions. One outer function, which is represented by f, and one inner function, which is represented by g of x. So when we have a function similar to v of x and we need to derive that function, in order to do that, we get the derivative of the outer function and we multiply it by the derivative of the inner function, which is g of x. So, below I've written some examples of functions that will require the use of the chain rule when differentiating. So, if we look at r of x, t of x, and k of x, they're all similar. Why? Because they're all composed of inner and outer functions. So, if we look at r of x, the outer function is cosine, and the inner function is 9x plus 2. If we look at t of x, the outer function is the power of 4, and the inner function is x squared minus 5. Same with k of x. The outer function is the radical. Why? Because the radical can also be written in the form of parentheses to the power of 1/2. And the inner function is 3x squared minus 3. Notice that it's very important for you to be able to identify the outer and the inner functions, because when we apply the chain rule to these functions, the chain rule tells us to differentiate the outer function and multiply that by the derivative of the inner function. To understand the inner and outer functions better, we're going to let p of x equals x cubed and t of x equals x squared minus 5 to the power of 4. Now, it may not be clear at first, but these two functions both have inner and outer functions. So for p of x, the inner function is x. For t of x, the inner function is x squared minus 5. For p of x, the outer function is the power of 3. And for t of x, the outer function is the power of 4. Now that we have identified the inner and the outer functions, we can differentiate them. So, when we differentiate p of x, just by looking at it, we could tell that all we have to do is apply the power rule to it, and we'll be done with it. But then if we look at t of x, it will be a little more difficult to differentiate it because we need to apply the chain rule to t of x. We could apply the chain rule to p of x as well, but what the chain rule tells us to do is derive the outer function. So by deriving the outer function, we end up with 3x to the power of 2. Then we need to multiply that by the inner function, and the inner function of p of x is just x. The derivative of x is 1. So we're going to end up with the same thing, 3x to the second. So there's no use of applying the chain rule to p of x. We could just apply the power rule there. So when we differentiate t of x, we need to manipulate t of x to make it look more like p of x. How can we do that? Well, we can let the inner function of t of x equal to u. Then we can rewrite t of x in terms of u. So once we do that, we end up with t of u equals u to the power of 4. So remember, we did not get rid of x squared minus 5. We just substituted with u to make it look more simpler. Now that we have t of u and we compare that with p of x, they look very similar, so we could just apply the power rule to t of u to differentiate it. Once we apply the power rule there, we end up with t prime of u is equals to 4u to the third. Now we just differentiated the outer function. Now we need to multiply the derivative of the outer function by the derivative of the inner function. And in this case, our inner function is represented by u, and u has a value of x squared minus 5. So let's get the derivative of that and multiply it with the derivative of the outer function. Once we do that, we end up with t prime of u is equals to 4u to the third multiplied by 2x. Now we can rewrite t prime of u in terms of x, and we end up with t prime of x is equals to 4 multiplied by x squared minus 5 to the power of 3 multiplied by 2x. And that's how you perform the chain rule. Let's look at another example. If j of x is equals to cosine of 5x squared minus 3, then j prime of x is equals to what? First, we identify the inner and the outer function. So the inner function of j of x is 5x squared minus 3, and the outer function is cosine. Step 2, we substitute and rewrite j of x in terms of u. So we're going to let the inner function of j of x equal to u. And we rewrite it in terms of u, so we get j of u is equals to cosine of u. Now all we need to do is get the derivative of cosine, and that's negative sine. So once we differentiate the outer function and we multiply the answer by u prime, and u prime means get the derivative of u. So we're going to end up with j prime of u is equal to negative sine of u times 10x. So remember, we just took the derivative of the outer function, then we took the derivative of the inner function, and we multiplied them both together. So lastly, we rewrite j prime of u in terms of x, and we end up with j prime of x is equals to negative sine of 5x squared minus 3 multiplied by 10x, and the chain rule is done.